Alright, let's look at Theorem 1, angle construction theorem. Alright, so let's say if you have two angles, one's bigger than the other one, so angle ABC is smaller than angle DEF. Then you can always find the unique ray EG. So I'm looking at this picture. So we can always find this unique ray EG. Alright. So that the angle, the measure of the angle DEG, which is right here, is going to be the same as the measure of the angle ABC, right? And also, ray EG is between ED, ray ED, and ray EF, right? So let's write a proof for this, right? So let's start with the given. Let's say given measure of the angle ABC is less than measure of the angle DEF, right? So 2. Right? Then we know that by A1, axiom A1, we know that there exists a number between 0 and 180. So I'm going to call this guy C, which is equal to measure of the, actually maybe I should say C, which is in between 0 and 180, such that actually, can I squeeze in one more? I'm gonna actually squeezing C and another one, say F, between 0 and 180, such that, right, C is the measure of angle A, B, C, and F, little f, is the measure of the angle DEF. Right, so this is by an angle axiom number 1, so A1. Right, so by 3, combining 1 and 2, we know that, let's say C is going to be smaller than F, and of course bigger than 0. Right, so this is just coming from combining line number 1 and line number 2. Alright, then what we want to do is we're going to set up a coordinate. So here let's set up coordinates on, let's see, F side of line ED. So F side of line ED, or maybe I'll say just ray ED, that doesn't matter, it's the same thing, right? Such that, right, ED is going to have the coordinate 0. Alright, so this comes from A3 part 3. Right, so basically we set up a coordinate here such that this guy has a coordinate 0. Alright, so we could do that. And then next step would be, so we can actually find phi, right? Since we want to match the measure of the angle DEG to ABC, we want to have the the ray EG to have the same coordinate as say as the measure of angle ABC. So we know that there exists a unique ray EG right, such that EG is going to have the coordinate C. So I'll just say coordinate C, right? This is guaranteed by A3 part 2. Because he says that every coordinate between 0 and 180, we can find a unique ray having that coordinate, right? So that's A3 part 2. All right, then if that's the case, so we know that this guy, we chose G specifically so that the coordinate is going to be C there, right? So let's look at the measure of the angle DEG, right? So 6, right? Measure of the angle DEG is going to be defined as absolute value of, right, coordinate of ED is 0, which is this guy right here, and a minus coordinate of EG, so that's C, right? And C is a positive number, so this is going to be equal to C, which is same as, right, measure of the angle ABC, right? And then so we actually could match that up, so we see that this part right here, we could match the measure of the angle DEG to measure of the angle ABC, right? Then we know that the measure of the angle, so this has let's see, coordinate F. Because of line number 3, C is between 0 and F. So by using the dual of theorem 3, so number 7, we can conclude the betweenness, right? So ray EG is between ray ED and ray EF, right? And this comes from the line number 3, because the coordinate has the betweenness, and also this is the dual of theorem 3, right? So remember that theorem 3 for distance, we have if we have betweenness 3 points, then the coordinates, their corresponding coordinates have the similar betweenness condition. And the dual of theorem 3 is the same thing, kind of analogous to analogy for rays. If you have a betweenness among rays, then their corresponding coordinates of those rays will have the similar betweenness condition. So if C is between 0 and F, then corresponding ray EG is between ray ED and ray EF, right? And this is pretty much all we need to do, so we just have to write down the conclusion. So number 8, so therefore there exists a unique ray EG such that, right, so we have the measure of the angle DEG is equal to measure of the angle ABC, and we have the betweenness condition ED, EG, and EF, right? So that's just a combining line number 5, line number 6, and the line number 7, right? So that's the proof, right? So this is very similar to segment construction theorem, just that now this is the angle version of a very similar theorem. All right, that's it. I hope that this was clear.